Now that we've taken a look at the walking through with the assumptions and everything in the linear regression, we're going to take a look at doing it in SPSS side by side with that packet and the job aid. So I'm going to scroll down and I'm going to get over to creating the scatter plot so you can see all of the assumptions walked through first before we conduct the regression for the last two assumptions and everything else. So within SPSS, you want to open your data set. So I'm actually going to close this window and I'm going to click open, and I'm going to use college student data just to have a sample. And this opens in my variable view. I want to move over to my data view so I can see all the points. So in this situation, I want to know if the hours of TV watched predicts the GPA. So if I want to know if the hours of TV watched predicts GPA, that means that my independent variable is hours of TV and my dependent variable is the GPA. So I'm going to go and I'm going to make my scatter plot first. So I'm going to go to Graphs, Chart Builder. I'm going to select Scatter Dot. I'm going to move the right one in, and then I'm going to bring my variables over and I'm going to click OK. So Graphs, Chart Builder. I'm going to go to Scatter Dot and I'm going to drag this one over in the upper right. Now I need to pull over my dependent and independent variable. So I want to know if amount of TV watched apparently it wants to be a little difficult today, predicts my GPA. Now this isn't the actual look of the scatter plot. We need to click OK. And this is my scatter plot, and so it does have a somewhat pattern here of linearity, like it is kind of going if I drew a line through it, but ultimately this might not be exactly a line. So I'm not really sure if you start looking at it, it might go this way or it might go that way. But that's how we would predict this line. For the sake of this exercise, we're going to proceed with this to see what we find, and then we'll make a determination about that linearity assumption. So if you were doing this in your dissertation, this would be a conversation to have with your committee and to say you want to do the full process, and then we want to know maybe a linear regression wasn't the best one and we should try a different one. But here's my scatter plot. So I can find my scatter plot, I can go in my document, and I can talk about the assumption of linearity because that's what that scatter plot relates to. I'm going to take this scatter plot and I'm going to put it here and I'm going to do my write-up beneath it. The next thing I need to do is to check for outliers. So I'm going to go into my appendix and I'm going to go to check how to run a box and whisker for outliers. So I need to go to Analyze, Descriptics, Explore. So I'm going to go to Analyze, Descriptive, Explore. And this is where I wind up. I want to know if hours of TV predicts my GPA. So I'm saying that my hours of TV is my independent and my GPA is my dependent. Then I'm going to go back to my handout and say, okay, now I need to select statistics and I need to make sure that outliers is selected. So I'm going to select my outliers and I'm going to continue. Then if I look at my handout, I need to look at the plots and I need to make sure that I'm plotting dependents together. Oh, actually they all need to be moved independently. That's my fault. Outliers and then plots, dependents together. and then I want to exclude cases pairwise. It looks like the default in plots was a stem and leaf, which I don't actually want. So I'm not gonna select that. And then my options needs to be exclude cases pairwise. And I say okay. And then I see my output. And you're gonna notice you're given a descriptives table, but really what we're looking for is that box and whisker plot. So now I can see my 2 box and whisker plots, and we kind of have a point here in question. That 12 is touching the whisker, so it could be an outlier because it's touching it, but generally we would look for it to be completely below it or completely above it. In this case, I think it's safe to proceed and assume that we don't have outliers. So that's how we're going to move it forward. And now I can finish my assumptions of my outliers. So I've got my outliers. I'm going to insert my box and whisker plot, and I'm going to talk about what I found. Now I'm going to move into the actual linear regression that has to be done in order to get those other assumptions. So I'm going to go to regression, linear, and then I'm going to declare my dependent and independent variables. So analyze, I'm going to go to regression, linear. I want to predict the GPA from the amount of TV that they watch. After I get that straightened out, I need to click the statistics button and make sure estimated and model are selected. And I see estimate and model is selected. I'm just going to enlarge this a little bit. In addition to that, I want confidence intervals, I want case-wise diagnostics, and Durbin-Watson from the residual. So it looks like I have more to check off there. So I want confidence, I want Durbin-Watson, I want case-wise diagnostics, outliers outside of 3, and I click continue. Now I'm back in my home menu, and I need to go to plots. So I'm back in my home menu. I need to go to plots, and in plots I need to pull over my Z residual and Z prediction. So my Z residual and my Z prediction. Once I do that, I need to select histogram and normal probability plot at the bottom right here, and then click continue. So I have my histogram, my normal probability plot, continue, then I can actually run the regression. And now you're going to see, here's that R value, here's my R squared. The adjusted one is typically the one we're going to reference, so approximately 4% of variation is found here. It's not a significant prediction because that's greater than 0.05, which should make sense if only 4% of the GPA variability is accounted for by the hours of TV that they watch. It shouldn't be significant. To be significant, it would have to be a larger percentage of it. Then I can find my prediction equation. So I'm not surprised by what I found, but I also still need to look at this. So for the assumption that utilizes the histogram, let's go back to that one up here. This is going to be the assumption for normality of the residuals. So if I'm looking at this, it's pretty close. I mean, there's just this one piece that's higher, so it does meet the requirements there. And then if I'm looking at my normal plot, let's see what I'm looking for in that normal plot. I'm really kind of looking for that I don't have a curved pattern. So I want something that doesn't have this type of increasing funnel. And in that case, I've got this pretty straight line and I've got this no pattern scatter plot. So here's what I'm using for that assumption of the plot, but I also kind of have this interesting linear plot here that's the regression of the standardized residuals. This would not be what you would put in your dissertation. This would be what you put in. So you can see that pattern is kind of scattered for this one. This one it created, we don't need. This is the one we need. So it does meet this assumption for homoscedasticity. So you put your image and there. So even though I did not get a significant prediction, I still have to write up all of my assumptions and talk about them. I still have to write up my findings for my linear regression, and this takes you through from beginning to end a linear regression in SPSS.